So let's jump into some examples. Our first example we can see is a parallelogram. So first on all of these, just identifying what formula we're going to be using and then making sure that we are plugging in the correct values for each part in that formula. So we only have two numbers here, but we do want to make sure that we are given what we're needed for the formula. We're noticing that we do have this little perpendicular symbol telling us that this length is perpendicular to the base. So that's what allows us to say, okay, if the base is 4, then the height can be 1 for sure. So our area is 4 centimeters squared. And this is the side of a pink pearl eraser, by the way. For example 2, still a parallelogram. So our base times height. Well, we have a couple of different numbers to choose from. So our eyes should go straight to this perpendicular piece and just noticing that this length of 10 is perpendicular to the base, even though it's outside of it, it's perpendicular to it. So if our base is 3, the height is 10. So we've got 30 millimeters squared. Not sure what that object is, some type of tile, rock maybe. For example 3, we've got a triangle, so our 1/2 base times height. Again, noticing that perpendicular piece of it, so if our base is 8, then the height of this has to be 5. It's the only length we have that's perpendicular to a base. And by the way, if I used one of these other sides as my base, that would be okay. I would just need to know the height to that base. So this is the only side that I actually know the height of it from there. So that's why I'm not choosing any other base. So we got 20 centimeters squared. And this was a Dorito, I believe. Cool Ranch. Sounds good. For example 4, another triangle. So you might pause the video and see if you can decide what the base and the height are going to be for this one. So don't be tricked by the 9. We're looking at that perpendicular piece. So if our base is 12, then the height is 8. And we end up with 48 yards squared. For example 5, another triangle, but we do have a word problem, so let's see if we can interpret what's happening here. We've got the height of the stairs is 12 feet, and the distance walking up the stairs is 15. Find the area under the stairs. So we're trying to figure out this area, this triangle right here. Okay, so if we go to plug in our base and our height, if we use 12 as the base, then we're missing the height because we need a length that's perpendicular to that. So we're really looking for this length right there. If we have 12 as the height, now we're missing the base. So it doesn't really matter which one is which here, but we do need this length. It is a right triangle, so how are we going to find the length here? I hope you said Pythagorean Theorem. So off to the side, I'm going to go ahead and have my 12 squared plus what I'm missing. So if you want to call it the base, you can. Or the height, it doesn't matter. So I've got my 12 squared plus my base squared equals 15 squared. And then solving for my base. And then solving for my base, I'm going to get that my base is 9. So my length here is 9, and now I can go ahead and find that my area is going to be 1/2 12 times 9, which is 54 feet squared. Example 6 is a trapezoid, so we'll be using that 1/2 base 1 plus base 2 times the height, or that mid-segment times the height, what we just learned. It doesn't matter which base is which here because we're just going to be adding them together. So we could do 4 plus 13 or 13 plus 4. Remember, those bases are the pieces that are parallel to each other. So as long as our height is perpendicular to one of them, it's going to be perpendicular to the other one. Just our rules for parallel and perpendicular lines. So the height here is going to be 7. And then I'm going to end up multiplying these 3 values, but make sure that you do what's in parentheses first. So don't distribute your 7 or anything like that. Go ahead and simplify what's in parentheses. You've got your 1/2 times 17 times 7, and you should end up with 59.5 1.5 yards squared. By the way, on your homework, I at least expect that formula piece where you're setting it all up, and then if you want to use a calculator from there, that's fine, but I at least want to see where you've plugged everything into the formula, so I can tell that you know what the base, height, etc. are. So for example 7, a little more challenging here. So trapezoid on its side, I still need the 2 bases and the height. So we've kind of run into some trouble here. I know one of my bases. The other base, I know that this piece is 5, but I don't know the other piece. So this is where what we've been learning with our right triangle trig or special right triangles could come in handy. So since I have this 60-degree angle, that means that this triangle is a 30, 60, 90. So since I have the hypotenuse and I'm trying to find the short leg, maybe you remember from that we would divide it by 2. So that means that my length right here is 2, which makes the whole base 7. If you didn't remember your special right triangles, you could use trig right here. So you could use maybe the cosine of 60 degrees is x over 4, and then solve for x. But remembering those special right triangles is going to be a good shortcut for several questions. So we've got 5 and 7 for our bases. And then again, right here, from here we could use Pythagorean Theorem, or we could keep using our special right triangles or use trig again. So continuing with the special right triangles, if I'm going from short to long leg, I would be multiplying by radical 3. So this should be 2 times radical 3. Again, if you don't remember the special right triangles, you could use trig. It's just going to take a little longer. So when I multiply this all out, I'm going to get 12 radical 3 inches squared, or you could have the decimal form if you use trig, or if you multiply it all out at the end, and that should be about 20.8 inches squared. And there might be an instance that you want to keep it in that radical form. All right, example 8, we're looking at a literal kite, and yeah, kite for math, kite for life. So remember that our formula for the area of a kite is 1/2 diagonal 1 times diagonal 2. So I've got all of my links here. It's just a matter of adding them together. So one of my diagonals is going to be 5. And then my other diagonal is 4. So that means the area of my kite is 10 feet squared. 10 feet squared. Okay, and then our last example, it's a diamond here, isn't it? But it is also a rhombus because we've got these marks to show us that all of the sides are the same. So we're looking at a rhombus. So remember we have those 2 different formulas we could be using. We could use base times height, or we could use that kite formula, 1/2 diagonal 1 times diagonal 2. So it just depends what we're given. So if we did use, say we used 5 as our base, that would mean that we would need a height that was perpendicular to that base. And notice that we don't even have anything drawn in like that, where if I use my 1/2 diagonal 1 times diagonal 2, I know that this diagonal, since my diagonals are bisected, is going to be 6, because I'm going to have 3 for this piece and 3 for that one. And then for my other diagonal, I don't know this length right here, but I can find it because this is a right triangle. So if I use Pythagorean Theorem here, this is going to end up being a length of 4. Or you could just remember it is a Pythagorean triple, 3, 4, 5. And some of you have those memorized. So one of my diagonals, my horizontal one, is going to be 6. And then my vertical diagonal, since I had 4 here, I'm going to have 4 at the top as well, so it will be 8. So my area here is 24 millimeters squared.